Good afternoon, everybody. Today we're going to integrate these two integrals by U substitution. Okay. So for the first one, I always encourage my students to look at what U substitution can we make to get a really, really convenient du dx, right? And so if you do enough of these, you'll probably notice that x squared minus 5 would be a really nice choice for our U substitution. So let's let U be x squared minus 5. Right, that means that we'll have the square root of u in the denominator. That's not too terrible to deal with. And conveniently enough, our du dx will be 2x, right? Now what that means is if we multiply both sides by dx, we get that du is 2x dx, right? Now we want 4x dx. And so if we want to turn 2x dx into 4x dx, obviously, all we have to do is multiply by 2, so we'll multiply both sides by 2, and so we get the fact that 2 du is equal to 4x dx, which means that we can substitute 2 du in for 4x dx. And so what that means for us is that our integral becomes the integral of, instead of 4x dx, we get to change a variable, and we get 2 du, and that's all over the square root of u, right? And so that 2 we can pull outside, and so this becomes 2 times the integral of 1 over square root u. You know what, even simpler than that, let's write 1 over the square root of u in exponent form as u to the negative 1/2 du, okay? And now we're set to integrate with respect to our variable u, and so that'll be 2 times, go up by 1 and then divide, so the exponent goes up by 1 to positive 1/2, and then we divide by positive 1/2, and so we'll have u to the 1/2 divided by 1/2, and then plus c, our constant of integration, right? We're getting into the part B's area, but that's okay. So we'll have 2 times, dividing by 1/2 is the same as multiplying by 2, so we have 2 times 2, u to the 1/2 is square root u, plus c, and now we should go back to our original variable, and so let's de-substitute u as x squared minus 5, and so our final answer should read 4 times the square root of x squared minus 5 plus c. And there is our integral, okay? For number 2, again, it's all about making a wise pick for the u substitution, right? So what u would give you a du dx that kind of falls into place within the integral, right? You might notice that a good choice would be negative x squared. And so let's try to box this off here. If we say for part B, let u be negative x squared, then all we'll have to deal with is an e to the u, right? Which isn't so bad. So if u is equal to negative x squared, then du is, instead of doing du dx, I'm just going to multiply both sides by dx right away, and I'll say that du is equal to negative 2x dx, right? Now, what we'd like is we'd like a positive 4x dx instead of negative 2. And so you might think to yourself, well, we can easily obtain exactly that if we multiply both sides by negative 2. And so that means that we can replace 4x dx by negative 2 du, and then we have an e to the power of u, and so our integral with this change of variables becomes the integral of negative 2 times e to the u du, right? E to the u from e to the u, and negative 2 du, the 4x dx, okay? And now, as always, we can pull that constant outside of the integral, and so we have negative 2 times the integral of e to the u du, right? And you guys know how to integrate that. That's negative 2 e to the u, right? And let's not forget our plus c for the constant of integration. And finally, let's bring it back to our original variable, x. And so our final answer should read negative 2 e to the negative x squared plus c there we have it. So, just get some practice in. Making that choice of U is really all that it's about. I wrote the first one dx. That's not something that I actually take the time to do. I'll usually just go right into du is equal to whatever times dx. That way it's really easy for me to see how it substitutes into my integral while I change the variable from x to u, and then I can go ahead and evaluate the integral itself. So, hope that helps. Thanks for watching.